With us, actually, I know Michael Serling well, but it's he's coming here. I was just thinking maybe should have waited a minute, but I already started introducing, so that's okay. It's a real pleasure to have Professor Alon with us today. He is here. Michael Serling will be here any minute, but Michael Serling, who's an environmental lawyer from the Detroit area, is the chair of the board of directors for Jewish Studies, and he endowed a visiting Israeli scholar position, which is being used by us to have Professor Alon with us this semester, teaching 2 classes at James Madison College. So I wanted to thank you, Michael Serling, who just walked in, for making it possible for Alon to be with us. Please, come sit with his endowment for this position. And of course, I wanted to thank James Madison College and Julia Grant, our associate dean, for being supportive of this and supportive of him teaching here this semester. So I could go on and on and on, and I was kind of, just as you were leaving dinner, I was saying it's amazing how much you've already accomplished. But in some ways, he's kind of an ideal person for us to have, both in James Madison College, which is multidisciplinary, in the Jewish Studies program, which is multidisciplinary. By the way, this is also co-sponsored by the Multidisciplinary Asian Studies Center and STEPS minor, as well as James Madison College. Because he is multidisciplinary himself, he had a law degree from the Hebrew University, but then got a master's and PhD from Harvard School of Public Health in environmental health policy. But also what makes him very interesting, I think, for a place like James Madison College is he's not only a phenomenal scholar, which humbles me and others. He's written about 100 articles and 6 books. The latest book is The Forest and the, give me the exact title.
All the trees in
the forest. Looking at forestry in Israel from biblical times to the present, published by Yale University Press. He published a book called Pollution in the Promised Land that my husband Eric Aronoff, who teaches in RCH, has used in our MSU Study Abroad Green Israel program. And he's published many, many books, one co-authored by Abed Rabo from Bethlehem University on Israeli-Palestinian water cooperation and what can be done in future peace agreements and things like that. And he's done work for years on those. So he's not only a phenomenal scholar, but unlike many of us academics, he's also started a bunch of non-governmental organizations and research institutes. So the Environmental Legal kind of Defense Fund in Israel, which is the main environmental advocacy group, the Arava Institute for Environmental Studies in the south, in the kibbutz Keturah in the south, which is an environmental institute which hosts students from all over the world and collaborates a lot between Israeli, Jordanian, and Palestinian researchers on common environmental challenges and solutions. But not that you think that would be enough, but no, because he's also chair of the Green Party in Israel. And so right now they're coalescing with a party now, Tzipi Livni's party, that just this week, polls show has the most votes. He's in that coalescing bloc, a left-center bloc that's trying to win the next elections in March. And he's the one for this whole bloc, which hopefully, well, I shouldn't be biased, come to power in March. He's doing all of their, while he's not teaching you guys, he's writing their whole environmental platform, agenda, everything for this coalition that hopefully will come to power in March. So he's got his finger in lots of pots, and even a few years ago, at a relatively even younger age, he got one of the most prestigious prizes in Israel, environmental prize from, well, it's a Lifetime Achievement Award, even though he was only middle-aged, for his phenomenal work trying to improve the environment in Israel. So he does this in the region-wide and especially in Israel as well. So it's a real pleasure. I've heard him speak before, and he's really engaging and knowledgeable, so it's a real honor to have you. And we'll have time for discussion and questions, and thanks for coming.
Thanks very much, Yael. It's really a delight to be here. I can't deny that there was a little bit of hesitation and perhaps intimidation as somebody who grew up in the south of the United States and spent most of his adult life in the south of Israel to face a January, February, March season in Michigan. But there seems to be a certain paradox that in contrast to the temperatures, the humans here, the people that I've met, have been so warm and so friendly. And I really want to start by thanking a lot of people. First of all, the students who've been great. And the only correction to Yael's introduction is it's not just me who's going to be writing a political platform, but people in our seminar will be doing this and surely giving us a better product. But really just the students, the faculty. I want to thank Michael Sterling really for offering me this great opportunity, and Eric and Yael, who have been just the best hosts anybody could want. So it's a delight, really a pleasure to be here today. So let's get talking a little bit. This gentleman is Boutros Ghali, who was the former General Executive Secretary of the UN. And he was very, very vociferous, as many people have been, in his concern about scarcity of water and how this was going to be a source of conflict in the world. And his famous quote is, that the wars of the next century will be about water, he said at the beginning 15 years ago. And this is something which is almost a cliche. You hear this, professors get tenure writing articles about all these horrible wars that are going to happen. Lots of books called The War for Water. But I don't buy it. And one of the reasons why is a friend of mine, a guy named Aaron Wolf from the University of Oregon State University, when he was doing his doctorate, he put together a database of all of the conflicts around the world, and looking at conflicts surrounding water, looked at 286 drainage basins, and what he discovered was that there's not really wars about water. That's the first thing we have to recognize. They don't end that way. There was one in all of recorded history. There was one war that took place, and that was about 4,500 years ago, between the Uma and the Lagash over the Tigris River. But in fact, we can say with some sense of empirical confidence that people don't really go to war about water. That doesn't mean that water scarcity and water disagreements doesn't exacerbate tensions between nations and between peoples and communities. That's for sure the case. And you can only, I spent a little time in California in the last couple of years and see their relations with Arizona and some of those upper riparian states in Colorado, realize that there's tensions all around the world. But the debate about whether or not water is going to be a source of conflict is really part of a broader environmental disagreement, okay? And on the one hand, you have a school of thought which you could call the cornucopians, the Prometheans, people who are fundamentally optimistic technologically, who feel that yes, there are great challenges environmentally and we have natural resource scarcity, but human ingenuity and technology can overcome them. And they would argue in the present context about whether or not that water on the one hand is not finite, because we can now make more water, and we'll talk a lot about that, that scarcity is a solvable problem, people have been solving it over the years, and that the institutional remedies are in place and proven, as is the new technologies. We just have to be smart and dispassionate and really thoughtful about how we go about doing this, okay? So their argument is that no, water is actually a source of cooperation. It's not a source of conflict, and we don't need all this kind of doom and gloom pessimism. On the opposite side of this debate are the people who are, we would call them neo-Malthusians, people who are concerned that there are real constraints on this planet, and as populations grow and as consumption grows, we're going to find ourselves in more and more trouble. And they would argue that yes, if you go around the world, fresh water scarcity is pervasive and it's growing worse all the time. And they would say that demand, people and lifestyles mean that water demand is going up all the time as water resources are dwindling. And so it's inevitable that existing tensions will get worse and worse and worse, and that's what's going to happen, okay? Now, there are plenty of examples around the world to confirm a pessimistic perspective. The Aral Sea maybe is one of the most famous. This is a sea out in Asia, which, as you can see, was a large source of fishing in the Soviet Union, but because the water was drained, that was supposed to usually naturally drain into there, was diverted for irrigation projects by the Soviet Union. Slowly but surely, the Aral Sea began to disappear, and you can see the progression there. And these are sort of the famous pictures that we have where boats are stranded in what has now become a desert. Dust storms, a public health disaster. I think I first became aware of this when Al Gore wrote his book, Earth in the Balance, and it hasn't gotten any better since then. So we have this as a model. Hey, Samantha.
Hi.
And that's not the only place on the planet. You've got Chad, Lake Chad used to be the second largest lake in Africa. And let's take a look what happened there. Okay, it was 2,500 square kilometers. It's down to about 2,000 square kilometers. Tens of thousands, hundreds of thousands of people displaced, their livelihoods canceled. Like, this is the way that particular ecological disaster looks. As an example, maybe as a metaphor of what happens as we lose this. But why go all the way to developing countries and blame this on third world mentality and poor planning? Right here in the United States, we have a classic example, and that's the Ogallala Aquifer. Okay, this is something I remember when I was in graduate school. They said, you know, the Ogallala Aquifer, the largest in the United States, which starts in the Texas Panhandle, goes all the way up there towards Wyoming, and you can see the map here, is dropping at a rate of 1 foot a year. And, you know, we can calculate when it's going to stop running in certain areas. And last year I was invited to give some lectures about water management at Texas Tech University, which is in Lubbock, Texas, an interesting place because it's the home of one of our great rock and roll stars. But this is what used to look like the fields around Texas Tech in Lubbock, Texas. And this is what it looks like today when I took a picture there. Because last summer, the summer of 2013, when they went to pump the water, it just wasn't there anymore. It had gone down to a level below that. And so all these croplands are going to have to revert back to rangelands. And for people who've been growing cotton and other crops there, it's a real crisis, okay? And this is happening now. So there are reasons to believe that water is running scarce. So we must start, when we start thinking about this, oh my goodness, this is one of those things. So this woman here is Mary Falkenmark, who is a Swedish hydrologist, a fairly iconic figure in our field. She was asked many years ago to sort of tell the UN, how much water do people actually need? Okay, because if we're going to talk about scarcity, we should do this maybe in an objective way. And she decided to make a two-tiered standards. On the one level, when people get to the point where they only have 1,700 cubic meters per person per year. And a cubic meter is 1,000 liters, okay, 1,000 quarts, so to speak, of water. So we're talking about a 1.7 million quarts of water a year. When you get to that level, she says you're stressed, okay? But when you get to the level of 1,000, then you're already scarce. Then you don't even have really enough for the fundamental needs of sanitation and growing the food, and that's really what where we're at, okay? So basically, the amount you need to grow the food for a year is about 1,100 cubic meters. The rest would be used in your things. But here's the deal. Look at the Middle East. 9 of 14 Middle East nations are living below the water scarce level in terms of the natural water resources. And one of them is Israel, and one of them is Palestine, and the poorest member of our Middle Eastern water scarce family is Jordan, which I'll talk a bit about. And so we have a situation where the baseline is we are low on water, okay? So, and how much we're going to need, it's only going to get worse. Sandra Postel, another one of our great pundits in this field, she reckons that we're going to need additional 40% for irrigation waters, and over the next 30 years, somewhere in the order of 20 Nile rivers are going to be required just to stay in place, okay? And where's that going to come from? So if you look at the map of water scarce, if you look at the Middle East, well, we're the bright red area, okay? This is probably the most water scarce region when we base it on an objective criterion for human needs, okay? Not necessarily that, okay? Now, if we're looking for reasons to be distraught, here's a good map. This looks like pretty much geometric growth. In 1950, there's 1 million people in Israel. 1960, 2 million people. 1970, 3 million people. And you can do the math up to present 8 million people. So the population is growing geometrically, okay? So that means at the very least, the water demand is growing. And it's not just this. Take a look at Jordan. There are only 500,000 people there in the late 1940s when it got independence. And this is before the massive increase in immigration or refugees that just came to the country. Here's the Palestinian population also, one of the fastest growing populations in the Gaza Strip. It's slowed down a little bit, but very, very much above replacement levels, growing with water scarcity to stop with. Here, take a look at this map. You can see Middle East known on the bottom here for more major oil, but in water, we're in trouble. And when we look around there, these are the numbers you want to look at, where people who are consuming more water that is naturally regenerated. Egypt's in a deficit, Yemen's in a deficit, but the champion is the Jordanians. So that's just something to think about. Let's think about just Jordan for a second. Just take a look at where they are. Every year, 565 million cubic meters of water. That's 565 billion liters of water they're taking out of fossil aquifers that have been there forever, and they're not replacing them. And this gets worse and worse. Today in Jordan, 2 days a week in the capital city of Amman, which is a wonderful town. I have many graduates that did study with me, and they're there, but they have to have a special system where they store the water on the roof of their house, and God help the Jordanian housewife who doesn't fill that up when she tries to do laundry or gives water, she's going to be in big trouble. So it's a very, very grim situation in terms of that, and this is the most recent pictures with 1.5 million Syrian refugees moving there, and they need water too. I was at a conference last year at American University, and they had on Skype the Jordanian water minister, and it was like 10 o'clock at night, and it was like a group therapy session. He says, I have the worst job in the world. We started the worst water scarce country. Now where am I going to get water for these people? And he was like 10 o'clock at night in Amman, and he was really feeling discouraged, and for good reason, okay? Now, Israel represents an interesting case study. And what I want to talk about is, where does our experience in Israel fit in this great debate about whether or not technology can solve water scarcity problems, or whether or not we're doomed and we have to do some very drastic measures in terms of a more sort of Malthusian perspective. So one thing you have to know about Israel in terms of the natural hydrological situation, and this won't be new for my students in the environmental class, is that Israel has a very, very steep rain gradient, an area which is really tiny, from no bigger than New Jersey, starts in an area which is hyper-arid, about 20 millimeters of rain per year, and can go up as far as some small sections of the Galilee actually tropical. 4 different climatic zones, okay? But the real thing that makes Israel unique is that we have a asymmetrical season, a Mediterranean climate. We have a lot of rain relatively lot of rain between November and April, and practically no rain thereafter. People who've spent time in Southern California find this completely normal, as do other people, but it does present certain kinds of challenges, as I'll talk about, for water management, okay? Because when you really have the drought and the tough time, the water's not available. So how did Israel deal with this difficult situation? Water scarcity, a imbalance where the south is low on rainfall, the north is very rainy, and the temporal asymmetry as well. So there's about 4 or 5 different stages we can identify in Israeli water management history. And what I'd like to do is walk you through them, and then at the end we'll think about it. What does it mean, and what have we learned from this for other areas? Because I should start by saying that I've often argued that there are 2 areas of environmental management where Israel's experience is idiosyncratic. Maybe it's valuable, maybe not, but it's definitely unique. And when we think about water management, I would reckon that Israel is almost like a fast forward towards the future. If you live in Australia or any of these other sort of water scarce places, certainly the American Southwest, what Israel's done is things that you're thinking about doing now because there's a shortage of water, and we have to think about that. So let's learn what we did, and let's see if we made mistakes and what maybe lessons could be taken from this. So the first stage, I said, was the great water carriers. I like to describe this period in Israel's history in the 1950s and 60s as hydro-socialism. The country is established with a strong socialist communitarian ethic where there's great social solidarity, hugely high taxes, has the lowest Gini coefficient in terms of income disparity in the world, and there's an unfair situation. People up in the Galilee in the north, they get a lot of rain. Folks who live down south, they're parched. So they said, okay, what we're going to do is we are going to share the riches, and we're going to take a giant, the largest engineering project ever in the Middle East at the time, to take water from the north and bring it on down south to the southern community so we can have agriculture there. Water is going to be sold at the same price everywhere in the country, even though it's a huge, I think at the time when they did this, it used about something like 40% of the electricity in the country, but this is something that was very compelling. And here's some pictures I'll show you. This is the grid where you take water from the Sea of Galilee, Israel's only freshwater lake up in the very north of the country. It's also the lowest freshwater lake in the world, so you got to pump it up the mountain, and then using gravity, it goes all the way down the desert. This is where I teach down here for those who know. And this is the plan, and this was a huge endeavor. Took over about a decade to do. It took something on the order of 60% of the foreign currency, but this was sort of like a Soviet 10-year plan. This was an infrastructure investment for the future. Here's a picture of how it looks from the air, okay? And basically we're taking water from the north down to the south. Now, if you live in California, this also is something that with which they're familiar. There it wasn't done maybe so benevolently. It was the the water barons of Los Angeles, and you can see the movie Chinatown if you want to get more details. But this is what the area looks like, okay? And indeed, the desert was bloomed and blossomed, okay? Areas that had previously been thought as wastelands and really lost for soil fertility have been brought back to life as Israel became a unique agricultural example of how you can take deserts, and with fertigation and enough water you can make it work, okay? But the trouble is that even then there wasn't enough water. So the second stage we had to do with wastewater reuse. When people began to realize that the sewage that they're flushing down the toilets was actually mostly about 99% water, and they could actually do something with that. They could use it for agriculture and other areas. And so Israel started a very aggressive program of wastewater reuse, starting by treating its sewage, because it originally had no real serious sewage infrastructure, and moving forward in 1956, a master plan, and that predicted about 150 million cubic meters of sewage a year. And usually water planners in Israel are overly optimistic. Here they're overly cautious. We actually know now that it's far more. The World Bank gives money, we're up to about 450, 500 million. Here's just an example of one of many plants where we take the sewage and we do primary treatment, where we separate out secondary treatment, we reduce the biological oxygen demand, and then we do the tertiary advanced treatment, okay? And these are the numbers. You can see just a enormous growth in the amount of wastewater being treated and then being recycled. Just to give you a sense, today Israel recycles 86% of its sewage. If you visit Israel and you're in a hotel and you flush the toilet, a week later somebody is going to be in an orange grove somewhere, and that same water will be watering this. The second country, I think, after them is Spain, with something like 16%, 16 to 18%. South Australia, I think, has 22%. It's a much, much higher percentage in Israel. So it's an experiment. It's an experiment which Arizona is getting into now. A lot of places are getting into it because it just seemed like the thing to do. Here's an example of a secondary treatment activated sludge area at White. Now, one of the interesting things that we had there when they started to do this wastewater recycling was the notion that a lot of the plants looked really bad. There seemed to be toxic impacts. And they started looking, they realized there was a lot of boron in the wastewater that was being recycled even after treatment. And the reason is that conventional secondary treatment doesn't remove boron. And boron's in very small quantities is a critical element. We all have to have it. But if you have excessive boron, you're going to actually poison the leaves. And you can see here the toxicity associated with excessive boron. So here, I work in public policy. Here we had a magic bullet. Because where was the boron coming from? It was coming from detergents, from people doing their laundry. So Israel just said, okay, let's just ban it. And in 1999, Israel bans boron in detergents. You just can't sell anything for that. And look what happens when the laundries of Israel stop using boron, and this is the concentration of boron in wastewater. It plummets, no longer a problem. So this is an example of a easy solution, relatively, where using there's technological alternatives, okay? The second part of this stage was the notion that when we start recycling wastewater, we have a problem. And that problem is this. In the wintertime, farmers don't really need the wastewater. And so they could throw it away, but in the summertime, there's going to be a shortage. So when you think about wastewater recycling as a national strategy or a regional strategy, you have to think about seasonal storage. And one of the things that Israel did is put in a couple hundred reservoirs around the country that store the wastewater throughout that winter rainy season that we're having right now, so that when June, July, August comes and the farmers really need water, it will be available. An interesting story. This is sort of a partnership between supporters of Israel's around the world through the Jewish National Fund. Almost all those reservoirs were built there. And 207 billion, it's a big infrastructure investment, but it has paid off. Now, this is a lecture which you'll hear very often, which this is a great achievement. Israel took something that was a waste and turned it into a a resource, and we should all be very happy. But the thing about environmental policy and what they pay us to do, they pay us to worry about things. And there's something called the law of unintended consequences. So one of the things that my own research now is focusing on when I'm back home, or actually when I'm back in my hotel room and writing my master's and doctoral students, say, where are you? And I'm out here. But there's this issue of endocrine disrupting chemicals. I don't know how many are familiar with this, but this is a sort of a new environmental challenge which people are beginning to deal with. The book Our Stolen Future came out quite a while ago, about 15 years ago. It was called The Next Silent String of Our Generation, and it was a journalist and a scientist looking at all these examples of bizarre things happening to natural populations in terms of hormonal impacts. Bizarre sexual characteristics, infertility, and this is things about fish and wildlife that have become exposed to certain kinds of chemicals. And they started putting together, they said something is going wrong with our hormonal systems, and they didn't have any evidence on humans, but they said we have to be careful, because if we don't watch it, what we're seeing now with fish, that there's all kinds of population crashes or whatever, it's going to start happening with people, because these endocrine disrupting chemicals that affect the endocrine system are going to be coming maybe into our world. Well, about 5 years ago, there was a little article about a study that was done, since it's been published in 2012, by a woman named Ronit Chaimov-Kochman. That's her picture there on the bottom of your screen. Now, Ronit is in charge. She's a physician. She's a doctor who's in charge of the fertility clinic at Hadassah Hospital. Okay, we have a pretty good hospital in Jerusalem, and Israel's very, very pronatal, and we subsidize all kinds of fertility treatments. And she said something's going wrong, because more and more couples are coming in, and I think if I'm looking at it, the drop in male sperm count is just, it's really crazy. And she did a study, and she did a comparison, and she looked at 1994 to between 1999, and then compared it to a decade later, and looked at things like the average sperm concentration and motility, and she found a 40% drop. Okay? Unbelievable. She said 2/3 of present donors are rejected because they're not up to standards, and by 2020, the average Israeli male will be, according to WHO, reproductively impaired. Okay? This is a new thing, and when I've often talked in Israel about the need to start talking about population control and reducing our very fast demographic growth, but this isn't the way to do it. So there's other this isn't the only kind of effect. We know that men's at the age of when young girls go into puberty has dropped 10 months in the last few years. Testicular cancer up 300% amongst Jewish males, 1,000% amongst Arabs. When I asked the professor who'd done the research about it, I said, clearly this must be a artifact of a false, maybe perhaps a better diagnosis or something like that, or false places. There's no such thing as false positives. If you have testicular cancer, you know it. So we have this thing going on, and what's the reason? And we're starting to see certain chemicals that are not susceptible to even tertiary advanced treatment appear in our wells. The first was Avadia Lev from Hebrew University, and then they started looking at some of the pharmaceuticals that are found in the best treated sewage in Israel. Okay, this is a friend of mine, Dror Avisar from Tel Aviv University, where you find 90% of the metabolized and unmetabolized antibiotics are secreted through urine, et cetera, et cetera. We're finding them all there. And now we have a study where we're looking with Palestinians, and of course the Palestinians who have practically no sewage treatment, only 10% of their sewage is treated, the EDC levels in their sewage is just really very, very high. So this is something that we're concerned about there as well. So just sort of wrap up that section before I go to the next part. The wastewater treatment is an important stage, but we're still in the middle of an experiment. And we haven't found the smoking gun yet. I'm not so sure that all these drop-in sperm counts because of wastewater reuse. But Israel does have a unique situation, and we have to be very, very cautious and very, very concerned and monitor this closely. Now the trouble is that even with the wastewater and with the water carriers, the country still has a water shortage. And part of the reason is this. If you take a look at the general hydrological map that I've been teaching for 20 years, this is the coastal aquifer, where there's a groundwater system that goes, this is the Gaza Strip, and it's connected there. There's the mountain aquifers, where it falls down. You've got the system of the Jordan River. And these are the, it's always great to give a lecture off of your Your computer, your friends are all on Skype. Let's hope they don't call me. Anyway, these are the numbers. And basically, Israel has its total rechargeable areas is 1,509 million cubic meters of water a year. That's the number, okay? That is the natural restored. That's how much rainfall it gets. But that's not the answer, because take a look at this. That's the number. Climate change is not the gloomy projection of Al Gore. It's a new hydrological reality. And for those who stayed up to hear the State of the Union on Monday night, I think Barack Obama was very, very emphatic about it. We've known this in Israel for a while. So if you take a look at last 17 years, the water's dropped to that, and in the last 3 years or something, about 820. A precipitous drop in rainfall. Okay, this is real numbers that we are concerned about. 2011 was the driest year in history. January 24th, not a drop of rainfall. It's the peak of the rainy season. We don't know what's going to be with 2015, but the climate seems to be changing, and it means less water. So we still need to find a better solution. And we see it in areas like the Dead Sea, which is disappearing. One of that reason is because the headwaters have been, that great water carrier that I told you about that used to bring water down the Jordan River, now that water goes to agriculture. Syria's been damming up the natural tributaries to the Yarmouk River, which flows into Jordan. And when the Jordan River used to bring down about 1,000 billion cubic meters of water, today it brings about less than 10%. And so the River Jordan, which was never deep and wide and chilly and cold anyway, has become a very small trickle. And as a result of that, there's all kinds of effects on the collapse of infrastructure. Streams are disappearing in general because of the loss of water and the overpumping. Israeli agriculture is suffering and the like. So the stage 3, after we've done this, was the newest stage, perhaps, is desalination. Now, desalination is something which it's sort of hard for you guys to imagine this in Michigan because it rains a lot here, and it doesn't seem like, I was looking at the water pressure in the place I'm staying at, and it's just amazing. I was like, they'd put me in jail for taking a shower this long and this full. But in areas around the world that don't have your kind of water, desalination is really the flavor of the month. Take a look at the Mediterranean Sea and see all this is already, this map is 2 or 3 years old. Several countries have added many sites to this, okay? So we know here's the looking at the Red Sea. This is what's happening. Everybody's doing it, a brand new desal plant. There's 17,200 desal plants already operating in 150 countries. This is a revolution in the way we're dealing with water. And for environmentalists, it's often really tough to deal with. We have to go to therapy on this issue. Why is that? Because for all those years, we've been preaching the gospel of sustainability. We live on spaceship Earth. There's limited resources. We're going to have to save every drop. And all of a sudden, they're saying, no, we can manufacture water. And as you'll see in a second, we can manufacture water very, very cheaply. So there's 2 different types of desal. We can go into it. For years, the leaders in desal were the Arab countries. They did distillation, but that's because they had unlimited quantities of oil to provide the energy. But as the technology moved forward, reverse osmosis using membranes was developed, and I'm delighted to say the first major membranes were developed at my university, Ben Gurion University. And as a result, this is what you get. These long membranes where you take water through, you push it through it at very enormous pressures. On one side, about 35% is left behind as brine, salty minerals, and the rest is pure H2O, okay? This is sort of the way it looks. You take the water from the sea, you get all the crud out in the pre-treatment, you push it through the reverse osmosis unit, and then you send it down, okay? Look at the costs as they've dropped. Because remember when I started getting in the environmental field, the conventional wisdom was that water was about $1 for 1,000 liters of water for a cubic meter. And look at the price dropping down to the 50 to 60 cent mark. A real revolution, okay? So think about that for a second. How much is your bottle of water that's sitting on